Let's say I want to factor 6x squared plus x minus 12, and I'm going to use a guess and check method. So I know that my initial values in each of the binomials either going to be 6x and x or 2x and 3x. Let me start with the 6x and x. My last two numbers have to multiply to be 12 or negative 12, but I'll focus on the 12. My combinations are either going to be 1 and 12 or 12 and 1, 2 and 6 or 6 and 2, 3 and 4 or 4 and 3. Now when I'm factoring, I know there's no common factor in the original polynomial, so I know my binomials should have no common factor either. And if I start to think through here, my options, if I put in the 1 and the 12, I will have no common factor within those, either of the binomials, so that's a possibility. But I can't use 12 and 1. If I put 12 in the first binomial, I'll have a common factor. Similarly, if I put 2 in that first binomial, I'm going to have a common factor of 2. Also with 6 and with 3 and with 4. So I know I can't use any of those combinations to get my factorization. What I can do, though, is I can try the 1 and the 12, and if I multiply that out, I'm not going to get positive 1 in the middle. So then the other option for me is to try 2x and 3x, and I'm going to run through that same process. Which of these combinations could I use that I'll have no common factor within my binomials? Can't use 1 and 12 because I'll have a common factor in the second binomial. I can't use 12 and 1. I can't use 2 and 6. I can't use 6 and 2. I can maybe use 3 and 4, so I'll pencil that in. I can't use 4 and 3. And then if I multiply it out, I'll have 8x and 9x, which is going to give me that 1x in the middle. And then I can work through my signs. That led us to a discussion of solving, factoring using this x method, where we're multiplying the first coefficient, the lead coefficient, times the constant, getting negative 72, and the middle coefficient is 1. And we're looking for factors of negative 72 that add to 1. That would be 9 and negative 8. So I had a student once who said, okay, and then I go 6x plus 9 times 6x minus 8. And I said, well, we can't do that because if I multiply 6x times 6x, I don't have the 6x squared that I'm looking for. And he said, well, no, that's okay because I'm going to divide by the common factors within each of those binomials. In the first binomial, we have a common factor of 3. I don't have a common factor in the polynomial, so I'm going to divide by it, get rid of it, and that's going to give me 2x plus 3. And in the second binomial, we have a common factor of 2. And again, no common factor in the original polynomial, so I shouldn't have a common factor inside my factors. If I divide by 2, I get 3x minus 4. And there's that factorization again. So he kind of combined two separate ideas together to come up with this method. His name was Fitzgibbons, so we call it Fitzy's method.